Okay, good morning, everyone. Okay, let's get started. All right. Okay, so today we are going to start our very first chapters, which we are going to talk about the power electronic devices. Now, like I said before, all right, before we go into these power electronic converters, we need to first at least know, okay, what are the devices? In fact, all these power electronic devices you all already study in your analog, okay? I mean, at least year 1, year 2. So it's basically more than a recap, okay? Or maybe something you may miss, okay, during your year 1, year 2 subjects, all right? Okay, now we start with components. As we know that electronics devices, all right, are those components where we connect them, okay, to make them a operational circuit. Now, in the field of power electronics, there are two types of component, passive and active. Now, the passive type, okay, is the capacitor and the inductor. And sometimes they will refer it as magnetic element. Now, it's important because if you go to the electrical industry, you tell the engineer, hey, where is the inductor? You will see a lot of question marks flying around their head. Okay? Or indirectly, you are telling them, this young man, new guy. In Cantonese, we call it 新嚟嘅. Okay? So that means you not really know the market. So same component in different community, they call it differently. Now, it is again very important to know this because you have to speak the right languages in the right community in order for you to work with them or to be recognized as part of them. Now, it may sound like, like a bit social thing already, right? Okay, it is very real, I can tell you, because I personally experienced this. Because the way you talk, right, they actually can know how well you know this area already. Okay, so if you talk about inductor, okay, if you are in electronic industry, who make electronic device, small device, okay, and you talk inductor, that is what we are taught here, okay, right? Now, in the research community, people are doing high-end research. They don't talk inductor. They call magnetic element. Now, your impression of inductor is coin, right? A coin. Okay, very standard, a small coin. But do you know that nowadays at the cutting edge of research, they no longer use this type of physical coin. Okay, they use PCB and they draw the track. Okay, and they put multiple layers and it already form a so-called transformer, high frequency transformer. So they don't have a proper name, so-called proper name for it. You can't call it transformer, you can't call it inductor, right? Okay, so they will name it as magnetic element. Okay, or to be more technical, right? They call it planar transformer. If you want to see how it looks like, see, you type inductor in this Google will recognize it at what we all understand it, right? Inductor. So it actually belongs to electronics domain. But like I said, when you move on to different domain, okay, so they name differently. Okay. You see, this is called planar transformer. It's actually, you see, they draw it on the PCB. It's a form of inductor. okay, is just another form of inductor. Now, when you, let's say, for example, when you type inductor, this is what you all study in circuit theory, right? So you know the unit, you know the calculation. But now you are year 4 already. Okay, we have to go beyond that. Now, this is all what Google image will show you. Inductor, 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 inductor. Oh, right? You see almost end of the page. For electrical industry, they call it reactor. Okay? In terms of symbol, it looks exactly the same. In terms of unit, it's also the same. In terms of the circuit theory equation to calculate all the reactive power or whatever things, it's also the same. The only difference is that it's the naming convention. Okay, it's not just I talk lah. Even the Google have to recognize it. You see, I type inductor. This is what we see. Okay, so now if you want to get the correct one, of course, you have to type reactor. Of course, it will show us the nuclear reactor. Okay. Let's see. Oh, maybe we need to type line reactor. Okay. Now it becomes more difficult to name it already. So this is not a transformer. You can see the symbol is inductor, right? But in the electrical industry, they call line reactor. It looks something like that. Very much bigger. I think this is one of the smallest you can get already in the electrical industry. Okay, so it looks like transformer. In fact, it's not, right? Because it's 3-phase. Okay, in the electrical industry, right, we always deal with 3-phase. So you will see, okay, 3-phase, 1 set, 2 set, 3 set of inductor. All right. So like I said, if you are talking to electrical engineer, you have to say, hey, where do you put the inductor? They will know what you are talking about. If you talk about, hey, where's the inductor? They have no idea. Okay. So it's important to have this domain knowledge. Of course, circuit theory is very fundamental. You say, okay, inductor is like that, Henry, right? And you calculate. But you come to the electronic design, you call it inductor. You come to electrical design, you call it reactor. Okay, so there is a difference in domain. And then the next one is active component. All right. Now, active component basically, okay, you just need to know these 3. It's more than enough for you to make a lot of converters already. So, of course, the first one is diode, very fundamental. Okay. Then the second one is thyristor. I'm not sure you all studied thyristor or not, got right? Thyristor. Analog electronic. Have you all studied this? Got right? So that means you all don't miss it. Okay. And of course, the last one is a transistor. So these are the 3 basic active components. All right. Semiconductor lah, in other words, okay, for this power electronics. Okay. Now we have to know first of all the passive one. Okay, the main difference between capacitor, okay, and the inductor. Now we know that, okay, capacitor also store energy in terms of voltage. Okay, capacitor store voltage, inductor store current. Okay, so they have different nature. All right, and then after it store the voltage, right, and it acts as a voltage source. Okay, you can be act as a voltage source. So you can see that this is the basic equation of the charging, okay, and discharging. All right, charging and discharging. Then the capacitor size, okay, is actually proportional to its storage unit. How many microfarad? Okay, the microfarad, the larger, the bigger. And also, even the microfarad can be the same, the unit can be the same, but the wattage handling capacity, okay, a capacitor can handle 100 watt, a capacitor can handle 1000 watt, okay, is much more bigger, okay, than those have a smaller wattage. All right, so that is capacitor. Okay, now we look at the capacitor throughout the spectrum of electrical, okay, and electronics. Now it can be as small as this one, okay, surface mount type, which you will see in a lot of our what we call small electronic devices nowadays. Okay, then these are the very typical one that students use to create projects, prototype, okay, or you get it from Jalan Pasar or online, okay. So these are the typical what we call through hole component. And of course, those, okay, this one, what we call this coaxial type, okay. So it's basically, you will see that, okay, they're using different material, okay, as this dielectric. And then this one, all right, and it's basically using ceramics, okay, or polystyrene for the dielectric, okay, or as a storage medium. Now, for these two, basically, all right, you will notice that this one, there is a polarity of plus and minus, right? Or plus and minus there, okay? Basically, this one is used for DC circuit. And then, like this one, there is no plus and minus. Most of this, any capacitor that is less than 1 microfarad, they usually don't have any polarity, okay? So that means it can be used for both AC and DC circuit. Okay, on this side is all electronics, all right? And we move on to the electrical industry. These are the capacitor they use. It's bigger than the Coca-Cola can, all right? It's bigger than the Coca-Cola can. And it comes with 3 phase, of course. That means there are 3 sets of capacitor inside one Coca-Cola can, all right? Now, you can only see this, okay, in the electrical industry. Of course, this is the example of capacitor bank, commonly used for power factor correction, okay, in our electrical industry. Now, power factor, right, as you all know that, okay, it's a measure of how efficient we use the energy, okay? If our power factor 1, beautiful, okay, you 100% utilize the real energy or real power. If the power factor, okay, is lower, okay, for example, 0.8, that means you only utilize 80% of the energy. The other 20% of energy are actually wasted, okay? Now, it's important in electrical industry because TMB, right, actually impose what we call a policy or regulation for anyone, okay, or any 3-phase user, including like UCSI, this building. If UCSI here, the power factor is lower than, if I'm not mistaken, is 0.85, then they will fine us, okay, penalty for that. So basically, all buildings have this problem. Okay, I would say all building. It's written very clear here in the TMP. You see, in Malaysia, we really need to know a lot about our electric supply industry, because there are a lot of things. If you don't aware of that, right, you are paying a lot of money without knowing why. Okay, so it is here, all right. So if we look at the power factor surcharge, all right. Now let's say you are taking, okay, very rare we take 132 kV lah. Okay, let's see, got a smaller example or not. No, they only show a high power. Okay, anyway. They even show you the equation, how to calculate, okay, the charges. Now, if your power factor, right, okay, is less than 0.85, okay, less than 0.85, then they will start to charge you 1.5% for every 0.01, so small unit, okay. And of course, if you don't care about it, okay, your power factor will go lower, right? So once it reaches 0.75, your charges will increase to 3%. Okay, or 3%. Don't estimate this number, you know. If you look at the bill people gonna charge, you can literally buy a kanji already. Okay. So here it will show you some calculation. All right. For example, the person bill is 2,000. All right. Then the power factor is 0.8. Then what will be the surcharge? Okay, so this example show that, okay, they will have a surcharge of extra, okay, 150 ringgit. Okay, so 7.5, you can see it go double. And it even go like 0.6, right? You can see that, you know, the charges is very high already. It's 1,002. Your bill is 2,000, but you need to pay additional 1,002 for that. Now, as we know that all buildings, what we call this electric bills, right? We are talking about K, you know, 30,000, 40,000 per month easily. Okay, 30 to 40,000 a month. So you multiply, it's a very lots of money. Okay. And then, like I said, what the industrial do is that they will ask the engineer to say, okay, come, how to solve this problem. Then the engineer need to know what caused the power factor. Okay, so basically the most common example is inductive load, right? We know that they are lagging of power, so it's inductive load. So in this building, for example, what are the inductive load? Anyone can tell me? Wow, very quiet. Anything that got inductor inside, motor, transformer, right? So aircon already got a lot of motor. So inductive load, okay, every place got aircon, they got power factor problem. All right, so what they need to do is that they need to compensate that, right? So they use capacitor. So they need to create capacitor bank like that, okay, and do some programming to monitor the power factor, all right, to make sure that it will not go below 0.85, so that you don't need to pay any surcharge. So by just doing this or know how to design power factor, all this, right, you already can have quite a steady income already in the electrical industry. Because any building commercial that uses three-phase will have this problem, okay? And then, you know, of course, you must know how to design because different size, different building, different size, different cap bank they need. And then remember, capacitor, right, will spoil one, okay? So it's a long-term business, right? You have it, you know, okay, after maybe 3 years, 5 years, you go and check, oh, this one's spoiled, that one's spoiled, please pay me, I do for you. Or for example, like UCSI is a good example. Last time we only got block A, block B, block C, D, that's all. Now suddenly got G, got E, more power factor coming in, right? So more business law. It's the same thing. The bigger the building you in charge, right? The more what we call this design fees, all this you can earn from that. Like Mid Valley, this types of mega mall thing, or expansion to garden, your money also expand, you know. Okay, like 1U, all this. So it is one of the industry, that's why I say electrical industry is actually very, very, very important. Remember I say electrical can do electronic, that is the reason. If the guy electrical, he can do this, definitely he can do all this. The problem is that you ask the guy who do this electronic, you ask him to do this, he had no idea what happened. Then of course, it not stop there. It can even move further up to the utilities. Utilities means that it's a TMB side already, because TMB also, especially at a high voltage side, they also need to make sure that, okay, the power factor is above 0.9, okay? So that is the TMB responsibility already. So what they did is that they have to do this cap bank, okay, in the utility size. You can see these are utility cap bank, okay? So if you have a chance to see this in the real utilities, then it looks something like that. High power, okay, what we call cap bank. Now in terms of cost, this one until today still 20 cents one piece, okay, less than 1 ringgit lah, I will say. But this one piece, 2 to 500 ringgit. That is the business margin we are talking about. You sell this capacitor 20 cents, how much you going to earn? 100%, 10 cents, no? How many you going to sell to buy you a lunch? And if you are this cap bank engineer, you sell one set of this, you can, you know, how many months you can. And you work on utilities, we are talking about 1,000. How many K already? Whole thing of this, you can buy a car, okay, or down payment for your house already. So in terms of career perspective and especially income, it's a big difference, I would say. Okay, unless you are working in a developed country, for example, US, UK, Japan, developed country, I had to put the word developed country, yes, electronic design have a good prospect and career there, but not in Malaysia. Really, not in Malaysia. So you have to think, I know that some of you are so sentimental on electronic, right? Say, oh, sir, I love electronic, you know. I mean, it's okay lah, but you have to think lah, you know, you love electronic, but less money, how? So it's important perspective, okay, that you need to know. Okay, up to this point, any question? Capacitor. Okay, because if I want to talk, I can talk more lah, but I think it's enough already for Power E. Okay, is for user with using 3-phase. Now that means if I say household, no, it's wrong, right? Now our household normal one, normal condo lah, landed terrace is 1-phase only, right? So you use until 0.5, they don't charge us. Doesn't mean okay lah, I would say TMB are kind enough lah, because at overseas country they see ours is 0.85, right? Already complain, say wallah like that. I tell you, some country 0.95 or 98 you know, that one is developed country, first world. So their power also really high quality. Now there are bungalow or certain terrace house, they can request for 3-phase, right? So they have a 3-phase filter, like, oh, Changi, you know, my house 3-phase, man. Then you have to be aware. Most of the people staying at that, they don't aware. So because also their bill not that high, 200 to 300, they don't see a bit different, you know. The another 300, it won't be so painful for them, I would say. Okay, so short lot usually have because short lot is 3-phase. Okay, so we are talking about whether you are taking in 3-phase or single phase. We don't usually say is this a house or not, right? Yeah. Well, I say lah, all commercial building lah, all commercial building. Okay, we have this. Even UCSI, I have been into the substation and see we also have this. And I see a lot of these spoil capacitor that the engineer replaced, but they put it there. Wow, a big pile there. I can count how much money UCSI spent for that. Okay, so yeah, I have a real one at my office. I should bring to let you all see and pass around actually. That make the physical class more meaningful, right? Okay, that's time I think. Anything interesting I try to bring. Okay, so any more questions? All right. Now, next one, we move for inductor. Okay, so like I said just now, inductor is the storage, okay, energy storage or current, okay? So it will act as a current source. It's a current source, and then the basic equation for charging and discharging, all right? So again, the size, okay, of the inductor is also proportional, okay, to the unit, how many Henry, and then the current, because it's store current, right? So the current capacity, okay, must be able to handle. Like capacitor, we are talking about voltage. So when you buy capacitor, right, you will see how many watt it can withstand. It will tell you how many amp. But for inductor, right, it will tell you, oh, this inductor is 3 amp, is 10 amp, but they don't tell you wattage, okay, because it is a current storage device. So, and like I said, it is under, sometimes we call it the magnetic elements. Okay, so it comes in a various variant. Okay, sometimes we call it coupled inductor, mutual inductor, high frequency transformer, and so forth. Okay. So, and in real, this is how it looks like. Okay, like I already showed just now. Okay, now this one is all electronics, small one, electronic. This one, okay, electrical. Okay, we call it reactor. And this one also electronic, but in the form of high frequency transformer. Okay, this one also. And of course, in the grid utilities, this is how the inductor look like. It's actually quite easy to recognize. They are always round in shape. Okay, they are always round in shape because it's a big inductor. So it's always round in shape. Okay, so this is one inductor. This is another inductor. Okay, and of course, in between this one, okay, is the insulator. Okay, insulator. And usually you will see this type of inductor and capacitor always together. They always come in pair, okay, in this high voltage industry. They always come in pair, all right? Okay, yeah, we are done on the passive component already. So for our power electronic, right, we are focusing more on, this type of inductor, okay, for power electronic converters. Okay, the next one will be the active component. The very first one is diode, okay, as we know that it is mainly used for rectifier to convert AC to DC, right? All right, you all should study this in the analog. And then semiconductor means that, you allow current to pass through in one direction, but block it in another direction. Okay, so it's a very basic, and we have this so-called forward bias, reverse bias, and the forward voltage, right? 0.7, some 0.6, okay, depend on the material. And then as far as we know, most of them are silicon. And then germanium, we got 0.2. Okay, that is what we all learned in the analog. Okay, again, now in power electronics, sometimes they will put the word power in front of the diode. If I'm talking about, hey, can we use a power diode to do this or not? Now, the word power means that we are dealing with either high voltage or high current. Okay, so that's why we sometimes really have to emphasize, I'm talking about power. You don't give me the small diode thing. Okay, so meaning that, okay, power diode have a larger power, voltage, okay, handling capacity, okay, instead of the signal. Okay, this one I get it from the textbook. I mean, all textbooks show it this way anyway. You know, the forward and reverse characteristic of the diode. As we know that, okay, okay, this part, okay, this one is the voltage, this is the current. So at this point here, somewhere this point here, usually 0.7 volt. Okay, when you apply more than 0.7 volt, then you will see this curve go up, meaning that, okay, it will turn on. Okay, current will go up. And then at this point, when you put the polarity negative, positive, reverse, okay, it will have a reverse bias. That means it's blocking. Okay, it's blocking the current. Then, however, there will be what we call a reverse leakage current. It's not 100% block. It will have a little bit of the minority carrier still allowing a very small amount of current, usually in micro ampere. So we unless you use a very what we call high-end meter, okay, only you can see this. That's why you will see there are always a reverse leakage. And then the leakage will become higher and higher as your reverse voltage increase. Okay, for example, if you put 10 volt, let's say 10 watt here, example, 10 watt here. Then you will have this leakage current and you increase double, for example, where it already hit the breakdown voltage, means that the diode can no longer block, okay, can no longer handle the voltage. Then what happens is that it will break down. So it start to conduct current. No? So that means your diode already spoiled. Okay, you will never have this problem in electronic industry because electronic 5 watt, 12 watt max. Okay, but in electrical industry, this play a very important role. Electrical, when we design electrical circuit or anything dealing with electrical, safety is the paramount. And we always need to double. Let's say like if your design is 100 watt, when you buy the component, we usually double it up. Okay, we always put 200. For what? For safety purposes. Okay, for safety purposes. Because there are a lot of electrical activity that can cause this to suddenly jump, okay, to that voltage. So it is important, okay, to what we call this, to follow this practice, okay. But of course, sometimes it's really very sad to see that when accident happen, right, okay, after investigation is, like for example, they're supposed to double up, but they don't double up. And of course, at the end, it's a chicken and egg problem lah. Okay, why I say chicken and egg? Normally, if the engineer is well trained, well practiced, he will do the design properly. He will code the thing accordingly. The problem is The client say, hey, so expensive, can discount or not? It's also part of the culture, lah. Some place they don't bargain one. But some place, everything bargain. So when this bargain thing happen, right? Say, okay, I'll give you 10% discount. And you feel like, wow, you're so kind. Actually, no. He just, he's supposed to buy double. He just buy a little bit, in order to give you discount. You ask for it, right? So that's why that kind, sometimes accident does happen because of this. Because if the guy, you may say, why the engineer don't hold on the principle? Say, no, my design is quality. You must get me. Sometime, you want to put the meal on your table, is one of the consideration, right? Okay, and then sometimes the client will say, so expensive, I find next door guy. Next door give me 10%. How? I give you one more time. Then, it creates this type of unnecessary competition. So it's really depend on the how the country industry actually, practice this, or it will end up with, like you say, in Malaysia, it's just like a culture already. Bargain in Pasar Malam is culture, culture, You don't bargain, you are something wrong. You are not Malaysian, You are stupid, something like that, Like, oh, okay, we have to, then it is, for me, is that, you are not actually bargain, Like I say, it becomes culture already, If I'm the seller, I will mark up the price. For you to bargain, it's just for you shock. Oh, you see, I bargain. Oh, 20 again become 10 again. You're happy, right? I mean, that is what happened. And in some country like UK, no such thing. You bargain, people look at you like stranger. Wait, where you from? Which cave you came from? Wow, then you feel like, you are one bargain. Everyone will look at you. Wow, like, oh, sorry, I come into the wrong street. Okay, for the component, this is how it looks like. Low power, super low power, high power. Now you can see, this one we still can put it on the PCB. We can still use soldering iron to solder, right? But you look at the high power one, there is no way you can solder. You need to screw it, You see, you need to use the screw to actually connect the power. You need to use not wire. We use copper bar. Punch a hole there and screw it. So that is for high power diode. And we have something like that. This is actually the size of your palm, your hand, the size of your hand. It's also in the form of screw. You just have to screw in. Okay, so these are high power diode. Okay, now in electronic, it's supposed to be end of story already for diode, right? Pass current in one direction, block, and how it looks like. Okay, and that's all. But for power electronic, we need to know two more types of diode. Now, the one what we study is called standard or general purpose diode. And then it comes with another two types called fast recovery. Okay, and the other call is Shockley diode. So I will explain these two later. Okay, I'll explain these two later. Okay, or it's a low, this one will give you a very low forward voltage, lower than those use germanium, what we call material. All right. High frequency, but of course the problem is that it will have a higher leakage. But we need this one to use it to increase, okay, certain converter efficiency. Now, for general purpose, like I said, okay, it is used for rectifier, and then the frequency it can handle usually up to 1000 hertz. Of course, more than enough, right? Our electrical system is only 50 to 60 hertz. That's all. Okay, so it's more than enough. And the industrial, I mean, the market lah. Okay, you can get is this on 1N. Okay, 1N5401 and 1M5408. Okay, so like I said, that's about it. Now the next part is that we are going to look more detail, okay, on how to read the data sheet, okay, and then use the data sheet to model the diode, okay, inside MATLAB. Okay, now modeling data standard diode in Simulink. Okay, why we need to do model? When we want to design something, right? We want to design it as accurate as possible to the real, okay, converter we are going to make, okay, or the real component that we are using. So if you use just the default, okay, you won't get the same result. So we will try to do that, okay. So this part will show you, okay, how to actually model a diode. Now let's take example like what I showed just now, 1N5400 diode, okay. And then in this data sheet, right, what we are interested is remember the forward bias, okay, the forward bias, okay. So we got a forward voltage and a forward current. So this data sheet show you, okay, if you buy this diode, this is how your diode will behave. Now, do you notice that, like, how come it looks so different from this one? This is the textbook, right? Textbook show you is this one, the forward bias. But the data sheet will show us like, terbalik. Why? Can anyone spot? I believe when you study this, right, your lecturer will tell you, oh, forward diode will look like that. Okay, right? Okay, this is the voltage. Okay, this is the current. I will tell you, oh, when it reaches this point, 0.7 watt, it will turn on. Well, how come this data sheet show us like, data sheet wrong? Can anyone spot the difference or why it looks different? Sorry? The high current? No. It's not about just the high current. Now, this part is important. Otherwise, you model until next morning, you cannot get this graph. So you have to first know this before you can start model this diode. Okay. Obviously, all the textbook show us in the linear graph. Okay, they show us linear graph, all textbook. But you go industry, they show you, see, semi-log graph. This is another thing. You will heard a lot. Where do you graduate from? This one you also don't know. You know, very old engineer will be like to scold young engineer in this way. Repeat it, so many times. I heard it until I want to slap him already. I mean, logically, if you were taught linear graph here in university, okay, your exam paper linear graph, and I didn't tell you today, tomorrow you work in the industry, okay, you look at it, you kalang kabut, right? Why is so different with what I'm learning? And then the old engineer will come like, big boss, where you graduate? You don't know me first class. Like, oh, I tell you. Okay. So that's why I think it's my responsibility to tell you all now. Okay, you get scolded, not my business anymore. Okay. Now, even you go to research, wow, so power electronic research institution, important. They will ask you, okay, well, now industry got this type of new diode coming out. We try to model it in Simulink and try to see how it behaves. Then your lead researcher will say, okay, try to model this. And of course, you open it and see, wow, what I learned in textbook is this one. Data sheet is this one. Oh, kelang kabut. Okay. All right. Now in Simulink, okay, another challenge. Now you know the difference here already. There are so many diodes. Okay, I listed out here 1, 2, 3, 4. Even let's say you go and open. Wow. Okay, no, discard. Okay. Okay. I'm gonna open this. Okay, usually when we want to get component from the Simulink, it's normal that student will go search, right? Or diode. Okay, try to search for diode. Then, or you will start to see different diode, right? Like I summarize a few. Okay, it will try to show you different types of diodes. Now, first of all, if you want to make yourself skillful in this Simulink, of course, first time, if you don't know, you use this one, okay? And after that, right, once you know, right, you will see this. Where is it from? Okay, you have to know where is it, because there are so many here. So when you just try to practice, okay, go there, it's under electrical, okay, it's in electrical, all right, and it's under, okay, semiconductor, pop here, straight away find it. Okay, so that you will not get the wrong one. Okay, now, of course, each of them, why they are different? Because they can model the diode in different way. You want a very detailed until the real, exactly like the real diode also can. You want it to be just a very simple, forward 0.7 or 6 and reverse totally block. Okay, also can. It's just up to you how detailed you want to go for it. All right. So what I'm going to show you today is when you talk about if you want to model until the graph one, which means that, okay, we want to model up to certain degree of detail. Now, to do that, okay, you need to download this one. Okay, I already put this, okay, in the Word. All right, so you can download this. Okay, now this is the model I created. Oh, wait, seems like people ask questions. Lo Chunin, give your friend the code so that he can join in, okay? Okay, where do I stop? So when you download this, okay, and you open this Simulink file, it should look something like that. Okay. Now, I call it the diode forward characteristic test bench. Now that will tell you, for example, okay. Now, how do you get this graph? Okay, how do you get this graph, right? So you have to create a model or that perform the testing, okay, so that you can plot this graph. This is how the industry use when they produce a diode, right? They need to put into a machine. To them, you just press a button, then they see the graph. Okay, they click print screen, put into the data sheet, happy. Okay. But now we have to understand that. Okay. Now to understand that, of course, now this is the diode. Okay, this is the diode. I call it. I mean, not I call it. In the practice, we call it DUT, device under test. Okay, device under test. And if you want to know whether you are getting a right diode or not, you double click it. Okay, it will open. Okay, then you look at the interface. Okay, then you will know, oh, okay, this diode allowed me to do, see, diode model. Diode model, okay, usually it got three ways. They got piecewise, exponential, okay, and then you can set your breakdown voltage. You can set the capacitance. There are a lot of things you can set, okay, but usually for the modeling, we will just need to do the main one. We just need to do the main one. Now, if you get the wrong diode, let's say, okay, maybe I just type this again. I just open one empty Simulink. Now, if you want to see the difference between diode, right, then you just drag it over. You just drag it over. Okay, this one, another one. Because they are placed in different library, okay? The name is the same, but of course, the detail level of modeling will be different. This is also diode. Okay, so let's say this one first. This is the one I showed just now. Oh, linear piecewise, right? You look at the model, you know, oh, this one you can model very detailed. And if you look at this one, that's all. Forward, how many voltage on register? That you cannot model the graph or how detailed it behaves. Okay, so this is a very simple diode. What they call it piecewise. Okay, and we have another one. It's also very simple, right? 0.8 watt or whatever you can type in to control or to model the forward voltage. Okay. So double click, you will actually know. Okay, are you using the right one? So for this one, okay, you should be able to choose and select. Okay, choose and select. Okay. Okay, let me put exponential first. And then, now, I already write a code in this, what we call this, blocks here. When I click, right, it will perform a test. So what this test does is that this is the power supply. And then you can see that it ramp up. Means that it starts from 0 watt, 0.1, 0.2, 0.3, 0.4, and ramp up. Okay, that is because I want to test 0.4, 0.6, 0.8, and I want to see what is the current, right? So that I can plot the voltage and the current graph. That's the purpose. And then you will see this two is what? This is the wattmeter. This is the wattmeter to measure the voltage across the diode. And then this A is the current meter. I want to measure the current across, okay, this diode. Current measure in series, voltage measure in parallel. As simple as that. All right. It is used in the industry where they just, program a power supply wattmeter, okay, and connect to the computer, then they can run the test, okay. Now, so once you run this, okay, you click one time, then your program should run. So after run, okay, I intentionally plot two graphs. This is the linear graph where you see in textbook, right? It looks something like that. And this is the, you can see semi-log graph where you see in the industrial or data sheet. Now you will see that, say, okay, the blue color line, the blue color line is the model in Simulink. And the dotted line is the data sheet, okay, graph. And then you will see that it doesn't model correctly, right? A bit different, okay? A bit different here. Some point here, a bit different. And then even in the semi-log graph, it also like, oh, not so right leh. Okay, not so right, but okay lah. It's still approximate, I would say. Okay, it depends on your requirement, whether your work, okay, this can settle, then okay. Let's say if you design a converter, they say, okay, not must be ngam and same one. Then of course you need to change the model. Okay. Change the model method lah. Okay. Okay, to tabulate IV, which I already key in all the information for you all. Click apply, click OK, and then you run again. Wow, now looks better, right? Wow, cantik. So that means if I'm using this model right now to do rectifier or whatever, right, it will behave exactly the same as what you get or what you bought, okay, the physical diode. All right. Now you may say, oh, sir, how to key in this information and that? Okay, like I said, yeah, while waiting, you all can start downloading this, all right? Then you run, see it works or not. Okay, now, when you open this, like I said, okay, if you want to model just a 2-point exponential, like I said, not so accurate one, okay, how do you know what to fill in? So basically what we did is that, okay, we take the lowest point. We take the lowest point, you see, this is 0.6. Half is 0.7. So roughly is 0.65, right? Okay. So the wattage V1, 0.65. Now the other wattage, okay, I choose 1.2. Why 1.2? Okay, because you look at this, the forward voltage is 1.2. It's not 0.6 or 0.7 that you learn in your electronic class. Okay, now, because this is a power diode. Power diode, when they want to increase the power capacity, the forward voltage increases. Do not always assume, diode forward sure 0.71. No such thing. Okay? So yeah, that will like say, oh shit, how come my output, difference or what? Then we choose this one, 1.2. Now, like I said, you are free to choose 1 watt also can, 1.4 also can, 1.6 also can. You can try all the possibility and see which one will give you the most accurate, I would say. That's why modeling takes time. It's not like one shot team. Researcher, they sit there 9 to 8, just model one diode because they need to do to make sure it's correct. Okay, now how about the current? Current is simple, right? Now, current 0.65, right? The current is 0.01, so you type this one. Then I2, okay, 1.2 watt here. Okay, so this is 10 amp, so 20 amp, right? 30 amp, but it's slightly lower than 30 amp, right? So 28. All right, and then the rest we don't do any changes. That one it will show what I show you just now lah. Okay. I never try all the range. I just simply tembak lah. I would say. Okay. And then of course, like the other one, you can use a tabulate IV curve. That's mean just now I only use 2 point only 2 point, your accuracy is limited lah. So you need to change the model. Change the model to tabulate IV. Tabulate IV means that, okay, you can follow all the points. So you can put all the current and the voltage law. Now, this one, you can put 20 point also can. Okay, so I just roughly lah. But it's good enough already. You can see it's overlapping, okay, with the data sheet. Okay, it's overlapping with the data sheet. Okay, now you can see side by side. This is the data sheet. This is your MATLAB model. Okay, this is your MATLAB model. Okay, now you can also model the reverse bias. Just now it's forward only, right? Okay, reverse bias, very simple. Again, look at the data sheet. Okay, now our data sheet, you can model like if you buy 5400, the reverse is 50 watt. So yeah, I get the highest lah. So I just key in the second tab. The reverse breakdown voltage is 1000 watt. So anything more than 1000, this diode will break down inside your simulation model. So you know that, oh, this diode actually cannot use. We need to increase, okay, or change some other model. Another factor is the junction capacitance. Now, the diode, right, actually have a capacitance at the PN junction, okay? But the capacitance is very, very small. It's in picofarad. But most of the time, we ignore it lah. Okay, even in I think in electronics class, we don't even talk about it, right? But in power, capacitance does affect. Okay, so it's important to actually model it. So where do you find this information? You see, in the data sheet, it actually tells you everything. It just we don't care about it only. The total capacitance is 30 picofarad. So capacitance, junction capacitance, you can model this. Okay. All right. Any questions? Okay. So yeah, please do it, see whether it can run or not. Those online, please download. Okay, run it and screen capture your result and post it in the chat box and let me see whether you are getting the right output or not. Because what you need to do is that with this model, right, you just need to change this diode. Okay, and then you can do the testing already. And if you want to see the real data sheet, right, it is actually, you can just Google it lah. Okay. Okay, this is the full complete data sheet. All right. So all the information I just extract from here lah. You know, the graph you see is actually from here. Nothing hidden. The most important is to model this one, the forward. Okay, the forward. Or you want to model the reverse against total capacitance also can. Okay, those online class come, be a bit proactive. Now you don't need to model, you just download and run only, you know. So how many of you can get it done already? Ah, 冇事發生. Okay, I walk around and yes. Wow, you see online one so effective, counting already. Oh, physical, must show physical power. Okay, let's see who is this. Oh, Jing En. Oh, you're online. Oh, very good. This one cannot count lah because she already very experienced in MATLAB. Okay, let's see who else. Ong Hui Guan. Tak ada gambar. Ong Hui Guan, how come I cannot see yours one? Maybe it's loading time. Very good. You see, I started with just download and you all run. Later, when we move on, right, you really need to construct the thing yourself already. Okay, so please try to familiar with it. Like I said, that's why I show you very detailed today. Where to find the diode, the difference. Okay, come on for those students online and yeah. Anyone counting already here? Or you have any difficulties? Or cannot run, cannot find? Yes. Oh, not showing up. Okay, now let me have a look. Oh, okay, come. change the version already. Okay, okay. Okay. At least I know the problem now. 2020 also cannot run. Of course, I use 2021 one. Okay, never mind. Now we see, so important, right? Version different, folder different, same project, not the whole class can run. So that is the reason why I want you all to try now. You don't have to tell me after next week assignment my method cannot run I will give you middle finger. Really, seriously. Because now it's week number 1. I will tell you, please do it. Don't come after why my model all cannot run one. I again give you double middle finger, I tell you. Okay? Now those sitting here laugh one, I know your face, don't come and tell me if you don't do now, okay? Okay, class, okay. Online one, okay, I'm aware of this problem now. We have this issue of a current, okay. I know that some of the students, you can see. Okay, Ko Sing Yi, okay. Dong Hong Yong, okay. Okay, now one thing, like I said, if you are first time using MATLAB, make sure that the file, okay, first thing, when you look at the screen here, you will have user, your name, document, MATLAB, right? Okay, store your file, create your model inside here. If you put it somewhere else, okay, it will not run unless you tell MATLAB where is the file. Okay, unless you tell MATLAB where is the file. Okay, so the problem right now, okay, it could be a version problem. So let me see. Okay. So what I'm going to do now is that I'm going to share this file called diode forward characteristic.m. Okay. Inside team. For those with the version problem one, try to download this. Okay, let me just upload. Okay, now you see there is a file here, .m, and when you copy, you drop it into, this one, the directory. And then what you need to do is you run this model one time. Okay, when you run this model, if this model is running, then what you can see is that you will notice the workspace will create a lot of this thing, right? Then after that, you open this file. Okay, you open this file and you run this one. It should be able to plot these two for you. Try it. Okay, online one, just try it.
Excuse me, sir.
Yes.
you please repeat how to use the files?
Okay, when you download the files, and you have to store it or save it in the same directory or the folder, okay, with the model. Then after that, you go to the file, or you can here type the file name, okay, diode forward characteristic plot, or you open the file, just double click and click run. Okay, you click run, then you can see the plot will come up. All right, try it. Of course, before that, you need to run your model. Okay, so I'll be walking around in physical class. You all can type in, then I'll come back.
Could you please send the file, sir?
It's already in team. It's already here. Inside team, file, diode forward.m. Okay, can or not? Oh, you want old version, then you upgrade lah. Then I will see our friend one. The one use the latest one, right? Oh, using the old version. Yeah, that's what I did on DVD. Okay, I think we almost run out of time today already. Wow, unexpectedly. Okay, no worries. Okay, so we will try to fix it. Okay, in the next class. Or while you all are at home, you all know this computer one. They can like that. How? But how come online one is a lot of them can done or so physical one no problem now? Wow. Okay, so I think it's almost time already. Okay, don't worry. Like I said, yeah, you can try this throughout the weekend. Okay, so at least you are familiar with MATLAB. Okay, when you see this problem, you know what to do. Okay. Okay, I think online one should be good. There are quite a number of students get it done. Okay, Huan, Brian. Okay, like I say, it's okay when the first time it doesn't run because you're not familiar and also some of the problem of the version issue. Okay, so don't worry, every class I will try to have at least some time we spend on this MATLAB so that it will help you to familiarize, by at least by the end of semester, you are competent, okay, in this MATLAB. Okay, Okay, it's almost time, physical class, because we need to go already. If you have any question, then we will discuss in the next class, all right? And then, yeah, because can't take any more Q&A, okay?